So in this video, I'll be going over this weird question that I actually came across. So I was looking at this question for a bit and I was thinking, why does it look so familiar? Now I'm going to show you why it looks familiar. So let's write it like this, right? So we have 3x minus 10, and let's write this third as its exponential form. It's going to be x to the power of a half, right? Is equal to 8. And let's actually just write it in a quadratic form, something that looks like a quadratic. And what we know is that this exponent is 1. So what do we notice about these exponents over here? This exponent here and this exponent here, both of them are half of the original quadratics, because normally we would have a quadratic where we have ax squared plus bx to the power of 1 and then plus c is equal to 0. That's normally our quadratics. And as you can see, this half over here is just the half of 1. And this 1 is the half of 2. So basically what we have is just a quadratic form, not a quadratic formula, a quadratic equation, but in this case, our exponents were halved. That is exactly what we're looking at. So how do we solve this? Now I'm actually going to go through it with you, because when I figured out how to solve this, I was thinking to myself, I'm a genius. So let's go through this together. So the first thing we want to do, right, is we are going to be doing the following. So if we want it to look like a quadratic, because we are so used to working with quadratics, we need to get it into the form of ax squared plus bx plus c equals 0, right? So let's do this first, right? So the first thing we are going to do, sorry about that, apologies, my alarm just went off. For all the initial defense, hey, your time has come. So over here, what we're going to be doing is we are going to be letting a variable equal to something, right? Or equal to x. And I'm going to show you why we do this. So first of all, what we're going to be doing is we're going to say the following. Let x equal to, we can choose any variable we want. But right now, because we like the letter k, we are going to write k. But take note, if we do just write k, we're just going to basically be writing a new variable, which we don't actually want to do. And I'll show you why we're actually going to write k squared. Because if we write k squared, within the equation over here, we're going to get 3k squared, which was x over here initially, and we have x over here, minus 10 into the square root of k squared equals to 8. Now, as you can see, right, this is the square root, so these two can cancel. And therefore, we have 3k squared minus 10 multiplied by k, and we're going to take the 8 over like this. So we're going to basically minus both sides by 8. In that case, let me show my work over here like that. Now you can see we have a quadratic, but in terms of a different variable. So let's actually just solve this quadratic right now. So what we can do is we can actually just factorize, right? But there's two ways we can do it. We can either do the grouping method, or we could use the quadratic formula, which is what we actually rather prefer. So we're going to use our quadratic, but remember it's k this time. Don't write x whenever you get. If you ever get a question like this, which I doubt it actually, just remember that you need to be careful of the variables that you use. Otherwise, you're going to have a weird solution and everything, it's inconsistent. You need to have consistency. So we know it's going to be the following, right? We have 3, which is a, negative 10. So 3, which is a, negative 10 is b. Let me just write it like this before you guys think I'm writing a fraction. And then we have negative 8, which is c. Okay. So in our quadratic formula, we know that it's going to be negative b, right? But our b value is negative 10. Plus minus, meaning we're going to have two different answers. And then this is going to be b squared inside, which is negative 10 all squared. And then we're going to have minus 4 into a, which is 3, into c, which is negative 8. I'm not going to write down the original form of the quadratic formula because I'm pretty sure you guys are used to it at this point. And then we have 2 multiplied by a, which is 3. And now if we put this on the calculator, we'll get the following solutions. Let me just put it all in the calculator quickly. Wait, guys, I just remembered. I almost broke character for a moment. I don't use calculators. Okay, let's do this. So we have k is equal to, okay, so I'm just going to keep simplifying here, right? We have positive 10, remember, because the negatives multiply each other, plus minus. and then we're going to have the root of, so negative 10 squared is just 100, minus 4 multiplied by 3 is just going to be, so we're going to write it like this in the bracket here, 4 times 3 is just going to be equal to 12, and 12 multiplied by negative 8 is going to be, and yeah, I got to that point where I'm just going to do this. It's going to be 8 multiplied by 2, which is equal to 16. Please learn your your timetables, by the way, please. And then it's going to be 8 multiplied by that, so it's going to be 9. So it's 96. So we're going to have, but remember, now there's a negative over here, so it's negative 96. Right? This is embarrassing. I shouldn't be struggling with my basic math over here, but it's fine. You're learning something. Cool. So we have 6 over here. Cool. Now from this point over here, we are going to simplify even more. I know we love simplifying. So we're going to have 10 plus minus, and then we're going to simplify the root over here. And then we're going to have 100 plus. So this is going to be plus. There's a negative and a negative gives a positive. And now we're going to have 100 plus 96, which is 196. And we know that 196 is 196, the square root of 196 is 14. Because the previous one, I think 100 square root of 169 is equal to 13, and then 196 is going to be 14. So we're going to have this over here, and then we're going to have k is equal to, and we can just write it like this over here, 10 plus minus 14 all over 6. And then we can just write it like this over here, where we have k is equal to 10 plus 14 over 6, or k is equal to 10 minus 14 over 6. Did I write 16? I apologize. It's actually 6. So then we'll get the following. We will have k is equal to, on this side, we'll have k is equal to 24 over 6, which we know is going to be equal to 4, right? So k is equal to 4, or, so I'm just going to write my ors over here, k is equal to 10 minus 14, which is equal to negative 4 over 6, which k is actually just going to be equal to, it's about negative 2 over 3. And there we go. There is our k value. There are our k values. So we don't need to use a calculator for any of this, because if we do use a calculator, then we are just minusing our aura points. And it is a lot of aura points, trust me. Unless you're in examination, then I guess, and you're running out of time, then sure. We'll let it slide for them. Okay, now we are not done. Remember, we solved for k, and now, because we solved for k, we still need to do, we need to actually solve for x. So, how are we going to do this, right? What we know is that k is just equal to, what is happening here? This is possessed. Okay, so what do we know in the beginning, right? We actually let x, so x was equal to k squared, right? But we want to find out what x is over here. But we have k, which is the subject of the formula. So in order to find k, we're going to do the following. We're going to have k squared equals to x, and we're going to root both sides, such that this will become k is equal to root x. And there we go. Now we have k. Now we can actually just substitute square root of x into this over here, right? So if you did not know what I did, just quickly go backwards, and then you should know what I did. Or we have root x, because we're substituting our k for root x, is equal to negative 2 over 3. And we can already see something does not, okay, never mind. No, this is squaring both sides. So what we're going to be doing over here is we're going to square both sides such that the such that the roots will cancel, or the root will just disappear, vanish, because of our exponent laws. So we have x is equal to, and then we have 4 squared, which is 16, or we have x is equal to, sorry, I forgot to write the square over here. So that's going to be a positive now. So it's going to be positive 4 over 9. And those are our solutions. And the reason, and now let's remember, we're not done yet. What we need to do is look back at our equation, right? So we had 3x, so this is our equation, right? We had 3x, it was minus 10 into root x equals to 8, right? So if we just substitute the x's in, right, so we need to do the following. What we are going to do is we're going to have 3, so let's deal with the 16 first. 3 multiplied by 16 minus 10 into root of 16 is going to be equal to 8. And then we are going to just do the mathematics, and over here it's going to be 3 multiplied by 16, which is just going to give us an answer of 48 minus 10 multiplied by root 16. We know root 16 is just equal to 4, so that's just going to be minus 40. And we know 48 minus 40 is equal to 8. And therefore 8 is equal to 8. So this one is true, so we can use that one. And then if we use the other one, and we substitute it back in, I want you to substitute it in to see if this is going to be true. So is this one true? That's what I want you to find out.